Okay, we're going to take a quick look here at the Fluid Power Lab. So the first question here, these were asking about short circuit protection, which if there's short, it's going to be a dead short. It's going to be a very fast situation. There's going to be a lot of high current, very, very fast, versus an overload. An overload could be a slower developing situation, okay? So if that's what's going on here, let's take a look at this. If for some reason there was a short on the solenoid, that means that it's no longer acting as a load. There's a direct flow of current here. Well, you would think that this fuse right here would blow right away, okay? If for some reason it wasn't sized correctly, and these up here with the path of least resistance, or the weak part of the circuit, I guess, then you would think that one of these would blow, okay? Because you got a complete short circuit here. And for some reason, these didn't blow, and there was a heavy load on the secondary here, causing a heavy load on the primary. Well, then one of these would blow, but you wouldn't think it would go like that. You would think that this one would be the one that blew first, okay? So when it talks about this, is there a short circuit on this? Yes, it's 1, 2, and 3. 1 fuse, 2 fuse, 3 fuse. And that means that there's a short up here, a very high current situation occurring probably in the power circuit. If there was a short down here and on the secondary, you would think one of these other fuses would blow before you saw such a huge surge on the primary, okay? So is there circuit protection on the control transformer? There is. That's what it is. That if for some reason there's a short down here, one of these fuses you think would blow before one of these did. And is there overload protection in the solenoid? Yes, there is. If it's shorted, it would blow, but there's also overload. And the overload means that this is heating up. So for whatever reason, that means it's not completing its stroke. It's getting fatigued. There's something wrong with the coil. You're going back, and the rate is too high for it, and it slowly gets hot. Well, then that would cause that fuse to blow for the overload. Okay. Next, look at the valve, and they want to know if this was hydraulic or pneumatic. Well, you would typically expect these arrows to be hollow if it was pneumatic, okay? So maybe that was a little bit confusing, and it is confusing. So the arrows were kind of showing us something that maybe it wasn't. But what a lot of people saw was that it shows an exhaust here. So this exhaust would imply that it was going out to atmosphere, and then that would be pneumatic, because you would not want to dump fluid out to the atmosphere. A lot of times this would have a T on it, said it was going to the tank, okay? So I didn't necessarily mark it wrong one way or the other. That's some things. These were some of the things. If you want to check your answers, this is showing that this limit switch, which is the retract, is being activated, okay? And I talked about what activates limit switch, both A and B. Take a look at your answers here. When does 1 LS activated? When the rod is retracted. So that's what 1 LS is working like that, okay? What activates limit switch 2? The movement of the rod and the mechanical arm connecting the cylinder rod positioned. Next page. When is 2 LS activated? When the rod is extended. Yep, that extends right here and activates it. When is 1 solenoid energized? So we need which port has pressure, and so that was going to be port A. Okay, so that would be port A here, and then because this clicks over to the other position, and it then would be pressure straight through to A right there. Okay, and then what caused it to come back is spring return, and it's a double acting cylinder right there. What are the numbers on the end of the line? The location, the CR contacts. That was my cross-reference right here, 2, 3, and 3. 2, 3, and 3. That's where they are right there. Describe step by step what happens. People did a nice job of this. When the disconnect is closed and 2PB is depressed, disconnect, brings voltage to the transformer. The transformer steps it down. When this is pushed, the control relay is energized because the limit switch is closed. here. And then the control relay closes, causing the solenoid to come on, and memory is created so the solenoid extends. List 3 ways in which this could be de-energized. You could open the disconnect, you could blow one of these fuses, or once you activate 2LS, this CR goes off, these open, and it goes off. So those were the ways there. Fluid powered. So now we're going to move on to figure 2. And so once again, is it hydraulic or pneumatic? Well, it's a little bit confusing here. I didn't necessarily mark you down because it's showing exhaust here instead of tank, but the arrows are solid, so it's contradictory. But we were actually doing a pneumatic system, okay? 2 limit switches. Once again, 1 LS is activated. Which contacts are being used? Because of that line here, we're using the normally open and the normally closed. What activates limit switch in the machine? Movement of cylinder rod, a mechanical arm. Excuse me. What activates limit switch 2? Same thing. Limit switch 2 is here. It extends. Okay. So limit switch 1 is activated when it's retracted, and limit switch 2 is when the rod is extended. Okay. When is the limit switch contact in line 1 closed? So the limit switch contact, or the 1 LS contact on line 1 is closed is when LS is activated, because this is normally open, it needs to be activated, and when the rod is retracted. So the rod retracts and activates it. And when is LS contact line closed? When it's deactivated, when the rod extended. It works opposite. When it's pressurized, port A has pressure. De-energized, which port has pressure? Neither port, because it gets 1 SOL gets energized, and that delivers pressure. And when you de-energize it, it goes back to the center position here, which is teed off. So its pressure's here is teed. There might be some pressure, and could be in the system here, but it has to come back here, and then this solenoid would cause it to retract, extend, retract. Neither A nor B. And it's for the position, what position is the valve spool in the center position? What is causing the valve spool to center itself? Spring. That's a spring here and a spring here. So we have the solenoid pulling it one way, the spring returning back to center. Solenoid pulling it one way, spring returning it to center. What loads are powered by that? All those. Describe what happens when the disconnect is closed and 2BP is pressed. Same thing. You press it because this is held closed, and because this is closed, the control relay comes on and we get memory. The control relay does the solenoid. The solenoid switches positions, causing the air and causes this to come out, which means that opens and that closes. But we have memory. It goes all the way out. It hits limit switch 2, which opens, which deactivates this relay right here. And because that is deactivated, this is closed. This is now closed. 2CR comes on, which hits the solenoid, which causes it to go back the other way. So everybody did a pretty good job of writing that out there. If it's halfway through the stroke, is it pop will stop the hold? Yes. If you break the power mid-stroke, it will stay centered. Okay. How will the circuit behave if 9FU is blown? Rod unable to retract. If the 9FU is blown, I'm looking right here, because this is our retraction solenoid. We would not be able to energize that, causing this to come over here, and the rod will not retract. Assuming all the parts we have steps halfway, yes, you got to turn the power off mid-stroke. I think it was one more here, a couple more pages. Draw a symbol for 4-3. Well, everybody did pretty good too there. What is the purpose of 2LS in contact line 1? What function does it serve? It opens the current path for 1CR when extended. Assuming reference, yeah, it will immediately reverse directions and tract. Okay, so that was on figure 1 because it was spring return. Spring returns I like, they're simple. We're going to talk about those later. And here were the questions for the back. interlocks for the 1LS. Okay. That's, and the piston rod is midway on the extended. What happens? It will move the reverse direction. And what happens? The rod will stop whatever position it powers when shut off. Okay. So that was a very quick run through of the lab. You can compare these answers to what you came up with.